This tutorial was brought to you thanks to the supporters on the screen. Check out TAPgiles.com to find more Dreams resources, donate to support my work, or engage my services to get private instruction or help on a project one-on-one. So there's a game called Lock by 800 Pixel Gorilla, which lets you walk up to like a panel in the world, and then you can press up, down, left and right on the D-pad to like type out a word into the panel, which with logic could get really hairy, really complicated, really thermo performance heavy real fast, unless you use some kind of clever techniques. So I thought I'd show you how to do some of those. And here's the little quick implementation I made. So as you get close to one of these storage nodes or input nodes, those things remember what letters that's already been input, and also what the answer is, like you press a button and then it checks to see if you got the right word. So it remembers what the answer should be, and also there's a word that it resets to if you press a certain button. So if I press square, it resets to this word, and I can like change it with the D-pad and so on. And then if I go over here, this has got a completely other different set of letters, and I can change these stuff as well. And if I press triangle, then it checks to see if it's the right word. That wasn't the right word. If I go over here and type in the right word, and that, and then press triangle, yay! Because I got the right thing. And then if I press square, then it will like reset again. So first, the key to making the thermo nice and low for this is to separate out the complicated bit and the easy bit. The easy bit just needs to store and change what the letters are, the current letters are, and the required answer and the reset word. And then we'll have a separate thing for all the complicated stuff. So the user interface, pressing left, right, up and down, and the display of the characters and all that kind of stuff. And then we'll just move the complicated bit to the easy bit, and it will kind of interface with each other and be able to talk to each other. And then when we go to a different part, like the one that was over here, it will just pop over there, and now it will be talking to a whole new word. So that should be fine. So first let's make the simple part, or we'll just like make a placeholder for it. So let's just make this glow a bit. And this will have a chip. This fleck is just so that we can group it up, which makes certain things work better. So this is our simple part, and then we'll just have a copy of that for the complicated part, and we'll have that not glow like that. So this simple part will have a tag in it to say where it is. I'll grab the gizmo of the tag, and then I'll press triangle to snap it to one of the grid points, and then I'll put it in the center of the face of that microchip, and then I'll give it a name. So this is the active word, and then I'll have this teleport to it. So I'll have a teleporter that looks for that same name, and we want to associate this chip with that group so that that whole group is teleported. So let's tweak the microchip and link apply to object to the group. Now any gadget in here will by default affect this group, so the teleporter will affect the group. And then we'll put that in the same place in the front of the chip, and now when we play time, that will snap to putting that chip on top of the other chip perfectly. And that's how we'll know we can kind of interface with it, and this can talk to that because it's right on top of it. But now we can't like see very easily where the complicated part is, so I'm going to just edit this and move that up. And now we know they're docked because they're like the two flecks are right next to each other. And but to be clear, we can just turn these flex off, so that when we actually, if we were to use it in a game or something, we don't need to see those flex, they just need to be there to allow the group to happen. Now we want to be able to talk between them. This will store, the main part of this will store the current 4 letters, and this will be represented by a single number, which we'll get into more later. It gets a bit complicated, but for now we'll just have like a random number, and we will communicate from there to there using Wi-Fi. So let's have a transmitter, and then on the other side we'll have a receiver. A transmitter sends and receives data from its position, and when a gadget is inside a microchip, then by default it just has the position of the microchip. So at that specific spot there on the face of the microchip is where this transmitter will be able to communicate from, and that's where we want this chip to go exactly over the other chip, and then it will communicate with receivers that are looking for the same name. So if we give this, I'll just say word like that, and we'll wire that in, and this is signal to receiver, so the receiver will receive this 0.7 value if we look for the same name, which is word. The transmitter doesn't have a gizmo to move it around or anything, but the receiver does. So I'll just put that on the face of the gadget again, and I'll just make the zone size really small because it only needs to look in that exact spot because we know it's right there. So if we use, and then this has a signal from transmitter. So it's sending into signal to receiver, and then that value comes out of signal from transmitter. And if we use a number displayer, then that will display that number. So let's put full decimal places like that. So now it's talking back and forth between them. And in fact, we can use, if we get another value slider, we can send in a different value back, like 0.2. And then if we grab one of those and move that across, then we will get signal from receiver. And now this is talking to this, and that value slider is talking to this. And we'll use this kind of stuff a bit later. But yeah, so this will represent the word that we want to display over here, and because this receives that value, it can then kind of pass it out and figure out what letters to show and so on. So we don't need that for now, and don't need that. Right, so now let's make a letter. So we want the display to have 4 letters, but they're all going to be exactly the same so that it's easier to kind of update them if we need to. So I'll put this chip kind of there. So I'm using L1 and up and down to adjust the grid size. So now I can have like a microchip, 4 microchips like that. You'll see how to do this later, but I want to be able to just delete those and then copy that across 3 times, and it for all of it to work with the kind of updated logic in this first chip. Let's do the rightmost letter first actually. So I want to be able to display characters, so let's have a text displayer. Say this is the A character, but we want it to be wherever this object is. When it teleports over here, we want that A to show here. So we need that to be, instead of on the screen, it will always be in the same spot on the screen. So we need to set that to be in scene. Don't want a background or a border, and I'll make it white so we can see it better. There we go, and I'll make it a bit bigger as well. Let's make that smaller. I want to make sure that the letter looks good when there's 4 of them. Yeah, so that's fine. But I'll need lots and lots of these letters. I'll need 26 letters and be able to cycle through them and all this kind of stuff and choose which letter to show based on what this says the current value is. So a selector wouldn't be enough. A selector lets you have up to 10 channels and kind of go through them, and then it loops from the end to the start, but you can only have up to 10. So we'll do this a bit of a different way. So for that we're going to use the timeline, and a cool trick that you can do with a timeline is if you click X on the clock time, now we have bars. I'll just turn off the grid, and if you tweak the timeline and set the meter numerator to 1, then each column has a new number. So now we can go out and say there's 26 columns like that, and we'll put that onto here and say that this should only be shown if we're in this first column, and then B should only be shown if we're in this second column, and C in the third column, and so on. And you kind of fill this out for all 26 characters. So we're going to find a value of what number letter we want to show. So like letter 1, letter 2, letter 3, for example. But for testing, I'll have a value slider. So this would go up to 26. I've got a normal value slider here that goes from 0 to 1. And you can wire that into the playhead, the bottom of the playhead there, and then if you give it a different percentage, it will go to that spot on the timeline. So at 0, it's going to show A, and if we just move that up a bit, now it's over the C displayer, so that C is being shown. So we actually want 0 will be the far left, so that will be A. So A will be 0, B will be 1, C will be 2. So if we set this to 2, then we use a calculator to divide by the total number of options. So there's 26 of them and 26 columns, so we'll divide by 26. Then wire that into the playhead. So if we gave that a 1, then that will be displaying B, and if we give it a 0, that will be A, and a 2 would be C. And if we filled this whole thing out, then we'd go through the whole alphabet. And I've found when you have something like this, instead of copying out a load of them with multi-clone with the right on the D-pad, they can kind of get out of phase, and then you've got to kind of tap all of them with R2 to get them to slot into the columns properly again. So now I'm just going to do them one by one. Now we have all 26 numbers, letters, so if we put this down here, we can see all those letters like that. And we have a way of taking a number and showing the corresponding letter for that. The next part is how are we actually going to represent all these letters, because there's going to be more than one letter. So there'll be 4 letters, so we don't just want a value from 0 to 25, which would be A to Z, but we want 0 to 25, 0 to 25, 0 to 25, 0 to 25. So we want 26 values for the first slot, and the second slot, and the third slot, and the fourth slot. If we were to do this with variables, we'd have 4 for each of these nodes. So we want to kind of combine these so that we can just have one number for that whole word, and that will also make checking to see if the word is correct and resetting to a particular word a lot easier as well. Thanks for watching. I hope you learned something new. Go to patreon.com/TAPgiles to get 5 hours of tutorials early for $3. Here's a preview of what you can learn if you choose to become a supporter.